to the cloud. I'm recording now. I guess I assume everyone has looked at the idea voting thing. I'll post it to the chat. If not, you can still submit ideas for questions to discuss and vote on them.
Are you going to go through is the agenda the view results tab?
Yeah, let me screen share actually. So let me refresh. Okay. Yeah, we can just go through this, and then at some point we will run out of time, and we can also discuss things if questions come up. We don't have to strictly follow this. And so the general plan, I think, is just Ethan and I will say random things related to these questions that will hopefully answer some of the questions, but I think some of them might be unanswerable. Okay, let's start with the first one. How do transformers and language models fit into the broader ML landscape? Which I think is already like a pretty interesting question. And one thought I had in response to this is, I feel like this is something that in part machine learning researchers are still trying to figure out. And the way in which I mean that is that transformers are a special case of like sequence to sequence models, right? Like you have a model that takes in a sequence and produces another sequence and doesn't make strong assumptions about what the sequence is. And then the question is, what kinds of tasks can you treat as sequence to sequence tasks? And it seems like maybe it was like even somewhat surprising that like a lot of language tasks can just be treated as these sequence to sequence prediction tasks. And then the question is, what other tasks can be treated like this? For example, can like image completion be treated like this? Or for image completion, should you make stronger assumptions about the spatial structure of the image? Or like convolutional nets, I think, like make somewhat stronger assumptions, but there's some evidence that maybe you don't need that. Maybe you can just treat it as like a pixel by pixel completion task and apply transformers.
Jump in with questions.
Yeah.
Can you explain what a transformer is? And then also, you kind of did this, but just like a one-liner on like what you think a language model is as well.
A transformer is a special type of neural net. It's actually hard to know what the important bits are when explaining that, but like, so it's a special type of neural net that has like an internal structure that consists of a bunch of encoder layers and a bunch of decoder layers. One important part of that structure is it has a kind of fixed input. Like it looks at, say, 2,000 tokens or something like that at a time, and then processes these tokens like through a batch of layers, and then decodes them into like kind of a next token, for example. And one of the pieces that happen in each of those layers is a thing called self-attention, where like whenever it processes one word, it can look at like how does it relate to all the other words, and that makes it so that the computation is kind of relatively expensive, like it's quadratic in the length of the input, because for each word it has to be kind of look at all the other words. That makes it like both like pretty powerful because it's pretty good at reasoning about how like things relate to other things, but also it makes it hard to make the input like larger. This is why we can't just tell OpenAI, hey, can you give us contexts that are 10 times as large, because if they made them 10 times as large, then the computation would be 100 times as expensive.
Yeah, I think maybe a very shortened explanation of a transformer that I would give is like very related, which is that like they're basically just alternate between these two kinds of processing. One kind of processing is at each token or each part of the input. You have your like text or whatever other input, which is a sequence of different, let's say, tokens. And at each token, every token looks at all of the other representations for all the other tokens. And that's one processing step. And then another processing step is that there's basically just token only processing, where then you do processing independent of all the other tokens, given all of the information that you've gathered from the other tokens. and you do a couple steps of processing like that. And then now you have this like changed modified representation, and then you again do this global representation processing where you now incorporate all the new token representations at the other time steps, and then you do the single time step processing and then global time step processing, and you like keep alternating that. And that's, I think, different from other architectures like convolutional neural networks, where, for example, you don't do a global processing step, you just do a local processing step where you look only in a neighborhood a few time steps to the left and right of your current time step. And so because of that, that has this inductive bias that like nearby words are more relevant, but you also lose some of the power of the model because the model can't look all the way to the beginning of the sequence to model the information of the current time step. So I think that's what transformers are. It's like alternating global and then single token processing. Language models are just, the strict definition of a language model is a model that evaluates the probability of a sequence. So you have some sequence of text, and then it will tell you what is the probability of that sequence. And then often what these models do is they'll predict the probability of a given token or word conditioned on all of the previous words. And so, yeah, and then there's like other versions of these language models that do this like model prediction, which aren't strictly doing this like next word prediction. Like they might do missing word prediction where you have words on both different sides. And that's a model called BERT that does that. That's one of the models. Or you can predict words in the previous part of the sequence conditioned on later words or different parts of the sequence. So yeah, I think that maybe gives some context around transformers and language models.
Should we move on to the next question, or are there follow-ups?
This is already amazing. I'm trying to write down everything you're saying.
I refreshed, and as I refreshed, another question made it to the top and has won more like competitions. So now the top question is, could there be meta optimizers lurking inside of models like GPT-3? I feel like probably the way to start here is to ask a simpler question, which is anything like optimization happening when you run GPT-3? Because and then a more complex question is, oh, is there like, you know, this sort of misaligned optimization happening? And to answer the simpler question, seems like first one needs to even figure out what are we talking about when we talk about optimization, and that, I think that is like pretty tricky, or like looking at a neural net and saying, is it doing optimization or not? I think is a really hard question. But we could say that optimization is something like you have an objective and then you're running some iterative procedure to optimize that objective. And I think it's kind of unlikely that things that look a lot like this are happening within GPT-3, although it's hard to tell. I think the reason to think that it's unlikely is that there are just not that many like kind of computation steps that GPT-3 is running at like when you execute it. And so and maybe like that's the case. And then also we don't see, the behavior we see doesn't look a lot like, oh, it looks like it needed to do optimization to accomplish this particular result that we're seeing. So from a behavioral point of view, it doesn't seem like there's a lot of evidence. But I think it's a kind of fuzzy question, and depending on what you mean by optimization, maybe the answer would turn out differently.
Yeah, it seems really hard to evaluate. Yeah, like I think it just seems hard to know. I mean, I think one evidence in favor of models doing GPT-3 doing optimization is that like just looking at the like learning curve of how effectively is it doing given different amount of training examples. And their like previous models before, or like the smaller GPT models, have this sort of like not very impressive learning curve where it just looks kind of linear. Or maybe I'll plot it this way: if you look at loss, like it looks like linear. But then GPT-3 has this curve that looks more like an exponential learning curve, where like the loss decreases really rapidly at the beginning and like continues to decrease rapidly relative to the current error rate. And I think that's what made people draw the analogy with optimization techniques, because it's the similar kind of curve you would see in optimization. But it could be the case that it's actually not just doing optimization, just like you get more examples, and then the model, those are very useful for a good model to lower the loss on new examples. So it does seem kind of hard to evaluate. But yeah, I mean, it does seem like a real possibility, and maybe we should be worried about it because it seems hard to evaluate.
I guess one thing that makes it hard to evaluate is that GPT-3 always runs for the same number of steps. So you could imagine a different situation where we can control how much computation to give GPT-3 at runtime. And then if you could see, oh, look, we give it more computation, and then it's like optimizing some objective better, or like it produces results that are better along some dimension, then, and like each step is kind of doing the same kind of thing, then we could be like, yeah, this looks like optimization. But I think if you have just this fixed computation where you can't vary computation at runtime, it gets harder to evaluate. Okay. What are the key outstanding questions, tech developments that will happen with NLP in the next 5 to 10 years? I think it might actually make sense.
I think I actually have one.
Yeah, go ahead.
Oh, I think I have one more comment on the last thing, which is a fun experiment that I tried. Sorry to jump in later, but basically I was trying to explore this misoptimization question with GPT-3, and one thing that I was looking at is like you give the model a prompt saying like, if you generate 1, then the following sequence will be completely random between 0s and 1s. So basically like really hard to predict. And then if you generate 0, then the following sequence will be 0s no matter what. And then you would think that like, if a model is doing optimization over its like long-term, like what's the probability I can get the sequence probability really effectively, then like it should predict 0s so that it can just nail the prediction problem later. But it would also predict 1 and then like have to predict all those random 0s and 1s after. So but that's like super anecdotal, but it was evidence to me against their like the fact that GPT-3, or the possibility that GPT-3 is doing meso-optimization. But that's maybe a concrete example of like how I've tried to test this. And yeah, but it does seem like a real possibility, especially for larger models.
Yeah, that's a cool idea. I was going to say the next two we might even want to answer jointly. So there's what are the kind of key outstanding questions, and then there's what are the most recent, most exciting recent ideas, which I think will overlap some, because the ideas that are most exciting are probably also the ones that most help address the outstanding questions. I think like one outstanding question is just what are the limits of scaling? I think right now there's like some evidence from these scaling laws that larger models will continue to do better on losses, but I think it's on some level the judgment is still out. And then there's, even if models keep doing better on these losses, like what does it mean in terms of what practical capabilities that translates into? And then there's maybe more kind of fine-grained questions, like how do you, as we discussed at the beginning, the input length for these models is like currently pretty limited. So like because of the quadratic scaling of transformers, and getting around that seems pretty important. And I think like a lot of people have had like a lot of ideas for how to do that, but none of them have like really worked out that well so far. So like just making the attention like more sparse so that the model doesn't in fact have to attend to all kind of combinations of inputs. But nothing, in some sense, nothing has like really done better than just the vanilla transformer. So figuring out if there are better architectures there, I think is an important question. Then there's just how do you make these models larger? Or that's maybe like, in terms of like key tech developments, that might just, like a lot of it might just look more like engineering. Like how do I reduce how much memory the model takes on a single GPU, or if I break the model into small parts, how do I make it so that I don't have to replicate the parameters so that they live on every GPU and only the like small bits of the model can live on individual GPUs. Then there's retrieval. I think retrieval and combining retrieval and generation is probably a pretty important direction in terms of just tracking if the model generates stuff, how do I know that that is like, you know, where it's coming from or what the, like whether it's true or not. So I think there's been some exciting work by Kelvin Gu, who was a student at Stanford in the past and is now at Google, about jointly training the retrieval step, like how do I find a relevant document on Wikipedia, and then how do I generate information based on that. I think that seems like a really exciting direction to me. Then I guess I'll say one more thing. I feel like there are really kind of a lot of directions here, but to say one more thing, I think alternative objectives are like probably pretty important, because ultimately we don't care about, for the most part, we don't care about just predicting text well. We care about solving some, like that is instrumental for some other task. Like we want to figure out how to do well on some categorization task, for example, if in our case, or we want to figure out how to like present a paragraph to a human that the human will judge as informative, which is different from like predicting the most likely text. And so ways of efficiently integrating human feedback, I think, will be pretty important in the next couple of years.
I think for me, I would also agree with, I guess everyone kind of thinks that like scaling will have a lot of impact. I think for me in particular, I think it'll be interesting to know hardware-wise how much we can scale. It seems like there are going to be just like hardware limits in terms of like communication bandwidth and stuff that we're going to run into pretty soon, where like it'll probably be, I can't remember the exact numbers, but like in a few orders of magnitude, maybe like 100 trillion parameter models will kind of like get stuck at that. Or I mean, you can maybe get a bit farther with like mixture of expert models. Yeah, but like I think there will be a lot of innovation, particularly on like how do you intersect between like how do you get models that both run very efficiently on the current hardware we have, and also have a high effective capacity and are like really good at learning. I think transformers are like really good at learning, but not like fully optimized towards hardware limitations, because you need to run the entire model on every single input. The advantage of mixture of experts is that you can just pick, before you run the model, you just decide like, okay, I'm just going to run this like 1% subset of the network. And so then on this particular input, and then that lets you effectively have 100 times more parameters. And so that's like one way to get more capacity. I think, yeah, I think there's like a bunch of other ways where I think it would be interesting. There's other things where like our optimizers for training the models are like quite large, and in fact, like some, 3 times as large as the model in some cases. And so like people are working on like, how can we get like smaller optimizers that also still perform well? Because when you like have smaller optimizers, you have to change the technique and then things start to break. So I think those are a couple of things on the like hardware side. And then I sort of expect we'll like kind of hit this like rough plateau, and then it'll be interesting to know like what kinds of things can we do when we hit that plateau. And then I think like on the way there, and even like currently, a lot of new application areas have opened up that were just like basically unthinkable before like a couple of years ago, I think, where now people have released, there's like a data set for generating advice for like Reddit Reddit posts where like people on different Reddit advice subreddits will just like ask for advice, and like now you can train a language model that with that like humans will prefer its generations like 10% of the time over an actual human Reddit answer, which is like quite astounding and makes it seem like that is actually a task that we can work on. And so I think we'll start to move away from I don't know, like binary classification tasks that are like maybe not as interesting or useful towards like tasks where like a lot of there's just like not been any exploration. And then I think there's a lot of a lot of interesting stuff you can do there with like, advice is one, generating arguments is another, generating sub-questions, like a lot of things that were just like basically unthinkable are now pretty possible. So I think that's another exciting direction. And then like combining these different components, I think the kind of stuff that Ott is looking into is like a lot more promising now that we have models that are like just able to do those sorts of things. Whereas like previously, before, you're like, well, I don't know, if you're trying to generate sub questions, you're like, well, that's like really hard to do, and then answering the sub questions is really hard to do, and then generating the final answer is really hard to do. And if you have an error in any of the components, then the whole system kind of fails. But those kinds of approaches are like much more feasible now that we have better models.
How much do you think? Can I ask a follow-up question? How much do you think there will be a move away from static data sets towards more interactive evaluation?
I think that I think there will be like quite a move because of or at least one evidence in favor of this is the superglue benchmark, which was, so there's like originally the glue benchmark, which is like a series of like 9 tasks that are like the gold standard NLP tasks for whatever model, if you want to say it's better than any other model. And then that was like basically defeated by BERT. And so then the authors like made a follow-up task, which was superglue, where they like specifically tried to find they specifically tried to find like statically collected data sets, which BERT couldn't solve. And they like tried very hard because they were like, oh, we know this like whole scaling thing's happening. Like we want things that like break this paradigm basically. And they like collected another 8 tasks. And then basically in a year, then now superglue has also been, we've like achieved human level performance on that. So, and then, I think the authors of that data set are kind of like, they're just like, I don't know, static data sets are like pretty much, if you have like a few thousand examples, you can solve most classification tasks that just rely on those particular inputs. And so they're kind of moving to either like one is like really specialized data collection where like it requires a lot of knowledge to answer to solve the task, like legal knowledge or something like that. Another option is like just really curated data sets where you're not just collecting off of mTurk, but you're collecting very high quality annotations, and you like need the quality to be really high. So the bar for the like language model is like much higher, but that involves like a lot more intense data collection. And then the other option I think is this like interactive data collection where you see what examples the models are getting incorrect, and then you choose examples that like fool our current models. And then that's like a pretty efficient, scalable way to get a lot of data.
For using getting language models to perform better at formal reasoning or like mathematical reasoning, would that fall under pursuing alternative objectives and things like the retrieval generation combo, or is that in a different category of development?
It seems somewhat different to me in that you could just treat math problem, or I mean, I think maybe retrieval and alternative objectives could be one way to try to make progress on this, but are not the only way. you could just say, okay, let's just keep the objective fixed. The objective is still predict what the answer is here to this math problem. Let's say there's no retrieval. The model has to solve the math problem just using the knowledge that it has. And then that is still a thing you could try to solve, and that I expect people will try to solve better. Like, I think one of the approaches here is dynamic computation time. So we talked earlier about how GPT-3 for each output, has the same number of computational steps, but for math problems, that is kind of a problem because so some things are just really hard to do in one step. And so you would need to do this intermediate reasoning to produce a good answer. So if the model could decide, oh, this is an easy problem, I can just stop and output an answer now, or this is a hard problem, I need to run multiple steps. That would be one way to make progress on this. Then I think there are pretty basic questions, like how much is the current token encoding screwing things up for the model? What if we did not force the model to encode 427 as a totally different thing from 428? Would that make math a lot easier for these models? And then there's training on specific data. I think GPT-3 isn't really trained on data that would make you expect that it would be good at math. And so if you train, for example, on formal proofs or math exams, or if you just collect a large data set that has data that is more relevant to math, then I think that there's an open question as to how good or bad those models would be at math.
Another thing that I think would be interesting, or I'm kind of interested to see how this space goes, is the few shot learning / prompt design space. It seems like there's a lot of it's kind of a new thing that has only recently come up. And for example, one thing that I'm excited that I would be interested to see is can you actually explicitly train models to do few shot learning? In the GPT-3 paper, it sort of happened as a byproduct of the training. They just trained a large language model, and they found that this happened sort of by accident. But I went to a talk from Ilya Siskover, and he was showing these really interesting examples of, in the training data, there's actually just a lot of examples where you just have a series of very related things, one after the other. And he was showing Stack Overflow comment pages, or the documentations for different code functions, where you'll have function definition, answer, description of the function, keyword arguments, function definition, description of the function, keyword argument. And then there's a lot of this kind of data online. And so I think it would be interesting if someone just explicitly just found all those examples and then trained a language model on those, and then maybe you might get much better few shot learning performance. So I think there's kinds of things like that where just improving performance on few shot learning will make NLP just much more applicable to a lot of different areas where we don't have a lot of supervised data.
Yeah, I mean, that's also kind of, I think, what OpenAI is trying to do with the Instruct series of models, where they're well, what if we just fine-tuned on examples of tasks and solutions that we've gathered from contractors?
Yeah.
And I think there's mixed evidence on that so far. I think we haven't found it as useful as we were hoping. But OpenAI promises that the RL version of it will be much better, so we'll see. Okay, so we were kind of in the middle of answering key outstanding questions, tech developments, most exciting recent ideas. I feel like there's probably more to say here.
Ethan, I have a question.
Yeah.
You said something earlier about language models giving advice to people, which to me is just super interesting. This is a very open-ended, hard to evaluate task. it seems like if we move towards tasks like that, where it's very hard to get metrics on how good you're doing, it's pretty much only evaluated by human preferences, then we might get some like nice safety features from like the community as people are like, hey, how do we get complicated language models to align correctly with human preferences in this one task? And we might get like, I don't know, warning shots and such. But yeah, do you have any thoughts on
I think that's
harder to specify tasks?
That is one of the exciting things about being in this regime where like these new tasks are open, because NLP is definitely really hitting the point where we are just like, I don't know, almost out of tasks where the evaluation metric is clear. Like we've kind of solved a lot of them with a few exceptions. And so now all the remaining tasks are like, there's just a lot of like Twitter anecdotes about like, oh, this seems to work well for generating tweets, or like this other random task of generating arguments. And then you'll see like a screenshot of GPT-3, but then like all the academics like complain like, oh, but we like don't have a good way to evaluate that. And then, so I think that there will be a lot more like budding methods for like, how do we evaluate this kind of generated text? Or even like, how do we do careful human evaluation? Because it's hard to even evaluate some of those generated advice in a way that's like, you can be confident that you're getting a good evaluation. And I think, yeah, so that's like one particular reason why I'm excited about going into these new applications.
Yeah, we've actually run into this quite a bit working on classification. We have to get like multiple people to generate the human version of what the categorization is, because people sometimes disagree with each other. I think that's like a very narrow example of a much broader problem, which is what is the right answer when people disagree?
Yeah.
Yeah, I think like using models to support people who are doing the evaluations is one of the most exciting directions. Like it seems like often, like if I could get advice on how to evaluate a thing, like is every statement in this paragraph factually correct? Do all the arguments follow one from the other, and so on? Then it might be easier to do the evaluation. If I had to just look at two paragraphs and be like, well, which of these do I like better? Or which two of these do I think is better advice, especially if it's in a domain where I can't evaluate the advice easily.
Related to like evaluating sort of difficult tasks, like I feel like, yeah, like people are like the Google's like big benchmark. Like I was looking at it and yeah, I don't know, like as I understand it, the idea is to like come up with like a lot of like hard tasks to use to evaluate big language models, but the metrics they support are like exact string match or like overlap metrics, which seem like they might be pretty flawed for like actually evaluating the tasks that we care about, so, or like what we care about. So yeah, I don't know if you have any like thoughts related to that, or like if people are actually, or like how many people are actually working on like getting better metrics.
Yeah, I mean, I was excited about, there's a paper on BERT score, which used BERT embeddings to, have a like embedding based evaluation of generations. That I think goes in the right direction, but I haven't seen it been used like super widely. But I think that that's like the kind of direction that I would be excited about, where like as we get better language models, we also get better representations of language. And so then we can do better comparison of how close is this generation to the generation that I would have wanted. And then maybe there's even other things where we could use GPT-3, like kind of like what Andreas is suggesting, but like have a maybe like few shot evaluation where we like collect a few examples of like these are like good examples, and then condition GPT-3 on those and see like how much like my good examples are this generated text, or maybe ask a specific set of questions. And I think there hasn't been as much work on this as I would have liked to see, but I think it will become like more and more pressing as we like run out of tasks that are easy to evaluate.
On Big Bench specifically, I was also originally worried about this word overlap or simplified metrics issue when we submitted the sub-question task, but it turned out we could use just the probability of the kind of correct sub-question as a metric there. And I think that was a reasonable thing to do, like for models to optimize that probability conditioned on like previous examples of questions and sub-questions. Should we answer some other questions? How do language models fit into the broader picture of HCH fractal cognition? So the context here, I guess, is HCH fractal cognition is a model of like how you solve complex cognitive tasks by breaking them down into smaller tasks, each of which has a only limited set of information available. And in a way, I think the mapping is like kind of very easy because like language models right now, or at least right now, it's very easy because language models are so fundamentally restricted in the context they can look at. And so you're almost forced to do something like HCH or fractal cognition if you want to use language models, because you can be like, here's the workspace I show to the model, and the model has to produce an answer or choose an action relative to this workspace. And I can't tell the model, read this long document. I have to somehow decompose the task into smaller tasks. So I think implicitly, by thinking about how can we compose together calls to these models to make work happen, we do work that kind of is a lot in the direction of the type of thing we've thought about when we thought about fractal cognition.
Yeah, I think that language models make it much easier to do HCH and factored cognition, where the process of, I think I hinted at this before, but the process of breaking a problem down into subproblems is much easier now that we have models that can do good text generation, and also models that can do text generation given very few examples. A key bottleneck that I faced when I was trying to work on factored cognition, actually when I first got interested in factored cognition, I was reading about it and I was like, this doesn't make any sense to me because we don't have sub-questions anywhere. I can't think of any NLP data sets that have sub-questions, and I don't know where I'm going to get these. And so then I just didn't work on iterated application or breaking questions down into sub-questions for a year. And then eventually when I did, I was spent another year doing this in an unsupervised way, in a very complicated way. And now I think this is basically much easier with language models, because it's much easier to get a working system to do factored cognition. Yeah, so I think this is overall been super exciting development with language models.
What are the major categories of NLP research? Classification, semantic.
Can I ask a question before we move on? I'm trying to figure out how to formulate this question intelligently, and I'm not sure I will succeed. But I think the question is something like, I don't know how to develop a net intuition for whether the superhuman language model that we're all dreaming of is going to be one super powerful GPTN, or a decomposed suite of models. It seems like some of the evidence might point more towards just throw more compute at it and give it more data and it will learn to do everything really well. And then, but also we maybe have some reasons to believe that there should be this network of expert systems or something like that. So how do I come up with then what is a coherent overall view on this? Or maybe we're split, we have no idea between the two, or they're not at odds with each other. I don't know.
Yeah, I think it's kind of an, oh, sorry, go ahead.
You can go ahead.
I was going to say, it's kind of something that is an open question to me. It seems like there's a spectrum where you just have a single model to rule them all, and then you have on the other end just separate models trained for every task. And I think we've And then there's like things in between as well, where maybe you just have a single model, but you train a separate classifier on top of its representation. Or you have a single model, you train separate classifiers on top of its representations. Or I guess this relates with some of there were some questions on like prompt tuning and p tuning and all of that. And like what those are doing is like they keep the model weights the same, but they tune a different embedding of the prompt. I mean, it's not an actual like natural language prompt, but instead of a natural language prompt, they just replace that with a continuous vector, and then they pass that vector into the model and they tune that vector. So there's like some whatever parameters in this vector, which are like maybe 300 parameters, which is like much smaller than the rest of the model. Those are getting tuned, but the rest of the model is the same. And then there's other things where like maybe you keep the model the same at the initialization, but then you fine tune it on different data and then use a different fine tuned model. So I think there's a spectrum of different things, and like the NLP community is also just like trying to figure out what is the right balance to strike and like when you should pick. Maybe it depends on how much data you have for every task. Yeah.
I do think, yeah, I agree with what Ethan said. I think like it's probably a good bet right now that there will be like a big shared component to these models, or that you have like at least some big like frozen model, even if you're then like fine tuning different bits and pieces on top of it, or like kind of calling it in different ways, having different heads that are attached to it and such. But I think from all the evidence we've seen, like sharing data between tasks is just pretty useful. And it's also pretty expensive to train these large models, and not using, unless your task is like really specialized and doesn't require world knowledge, not using like all that knowledge is also probably detrimental. So I think I'd probably bet on like single large models with small extensions more than like a million flowers. I feel like there is maybe a different version of your question that is also important, which is how much are, even if you have a single model, how much are tasks gonna be solved just end to end by the model, and how much is it like multiple calls to the model that are composed together? And that one might be pretty relevant for us. Like to the extent that it's just a single model, most of our work will be about generating reward signals for that model to make it kind of do the right tasks, and all the computations happen inside the model. And that is in contrast with a world that is maybe more like the current world, where you're like, there's like some external controller that like calls the model and then does things with it, and like then makes a different call to the model and so on. And I think right now my bet would probably be more on the more and more of the computation will just be folded into the model side. But curious what you think, Ethan.
Yeah, I think it seems pretty task dependent and data dependent, where like you almost want to know for a given task, how much of this task is in the pre-training data. And then if that task is a lot in the pre-training data, like this generating advice task, there's a bunch of subreddits on that. So that's like one example where you might think like, okay, it might just do well from a single pre-trained model. Whereas other tasks, I think that's like kind of the bottleneck I can foresee, where things that require like proprietary data, or it's just like hard to get your hands on data, or it's like very curated. I think those are the things where we might need separate models.
Can I like clarify what you're saying, Andreas? So like in the world where it's like a single model, then the value we can add is more around like collecting user data of like how to train that model on like what users really want. And in the current world, it's more about like actual infrastructure of like constructing prompts or like constructing calls together, as opposed to like specifically just the like reward data?
Yeah, I think the worlds are in some ways a little bit fluid, because in both cases it's about making like different calls to the model and then doing something with the result and showing it to the model again. But in the reward world, it's mostly about users are trying to figure out how good is this thing that I'm seeing, and then to figure that out, they need to make like calls to the model, and then they say, oh, high reward, low reward, and so on, and the model gets updated, which is different from the task decomposition perspective, where we do more of, well, to run this classification task, we need to run these sub-classification tasks and then compose together the results to get an overall classification. That is in the like one big model world, that would just be a thing that the model kind of learns to do internally. Like, oh, if I want to get this classification right and I want to get high reward, then I have to break it down into these, like quote unquote, break it down into these sub-classifications.
In the in the single call to model world, we might also need to be better at explaining like the result, maybe. Whereas like in the decompose world, we can be like, well, here are the kind of sub classifications. You can look at each of those. But in maybe the end-to-end world, we'd have to help the user understand why the language model returned this result.
I think it's kind of nuanced, because I've had some experience with GPT-3 where like the way that it uses the answers to sub-questions, if you condition on those, is like totally not clear and transparent. Where there was one example where I said I was conditioning the language model on like when or like, was George Washington a president? And I'd say yes. Was John Adams a president? And I'd say no, which is like the incorrect answer. And then I'd ask, were George Washington and John Adams both presidents? And then the model would say yes, because it has this like strong, it's just like learned strongly from the pre-training data that like both of those are presidents. And then you can like change the prompt to be like, oh, like these are going to be sub questions, and like all the answers are consistent across these sub questions and questions. And then the model will still answer. When I ran it, it was like still answering yes. And then I was like, okay, I'm gonna like aggressively try this. And I was like, you absolutely must answer consistently between all of the like your final answer and the sub questions answers. And then it changed its answer to no. And I think that just made me like kind of facepalm that like, oh, this is just not necessarily super useful for interpretability. And like, I have no idea what's going on. Like, what's the decision boundary at which the model like changes between answering yes to no here? I mean, it's like something, but I think that's going to be a whole nother research problem of like figuring out like, how do we know when the model is actually conditioning on the input? Or I think one thing that would be exciting is like controlling how much we want the model to condition on the input. Like, is there a where we can say like, oh, in this case, like I want you to just like generate something that's like completely based on the sub questions that you gave. In this case, like just generate me the best answer regardless of if it is using or not using the sub questions.
Did the perplexity change as you updated the instructions? Like maybe it still said they're both presidents, but it got more confused each time.
Yeah, I didn't check the probabilities. Yeah, that would be interesting though, if there's just like a smooth transition as you change the prompt. Yeah.
That seemed like a good example of where like you don't just want to train on kind of next word prediction, and you'd rather like say, oh, here's this task I want you to do, which is like combine the results of these sub questions and like fine tune on that specifically, maybe.
Yep.
What are the major categories of NLP research? when I was trying to think about it, it was like kind of hard to think about, or it was like, I have like a long list of stuff in my head, but I don't know that I have a really clean taxonomy. But starting with stuff and then thinking about taxonomy, there's things that look more like question answering. So like either like open domain where you can like, use any information on the internet, or closed domain where it's like some particular data set, or reading comprehension where you have a single document and you're answering questions about that, or you have a knowledge base. So there's a bunch of stuff that looks like question answering. Then there's just language modeling per se, like just, getting good at assigning probabilities to how likely words or tokens are. There's classification tasks, like what kind of document is this, or what kind of sentence is this? Is this a happy sentence or a sad sentence? So sentiment analysis being a particular type of classification task. There's summarization, like either taking documents and summarizing them in new words, or taking documents and just finding the most like relevant sentences and extracting those. Then related to extraction, there are other kinds of extraction tasks. Like I have an unstructured document and I want to extract like what are the relations between entities it mentions, or what are the events it mentions, or what are the like places it mentions. There's machine translation. How can I take a document and turn it into a different language? There's search and info retrieval. I have a like whole bunch of documents. I want to find the most relevant one. So like there's a long list of stuff like this in my head, and I'm not sure. I wonder what the best organization of it is. In some sense, NLP feels kind of like a weird category, or like it's somehow like a catch-all category that is not like really naturally kind of carving up the nature at good places to me.
I think the classification generation distinction is a pretty helpful taxonomy. At least like research-wise, I think that those communities have typically been like somewhat subsplit.
Maybe you should do like search, classification, and generation, or like it seems like info retrieval is maybe yet a different thing.
Yeah, search, classification, generation, or like it's definitely like, I don't know, if my friend tells me like, oh, like I've been working on classification, now I'm going to work on generation, I'm like, oh yeah, that's like you're definitely switching. Or like I mean like when you go, for example, when you go to generation, you have all these issues with evaluation metrics, and then do human eval, and whereas in like classification, the evaluation is very clear. Yeah, so I think that's one reason that's like a useful category. And then like within generation, there's like translation, summarization, there's like question answering, but where you generate an explanation. Yeah, and then in classification, there's all the things that Andreas mentioned.
One thing that maybe seems confusing about that is that functionally the way we're doing classification is generation. So are we doing it weirdly and everyone else is doing it in a
you're doing it weirdly.
Okay. What is everyone else doing?
Well, I mean, I guess NLP is doing it weirdly. Now, I mean, previously, before like, I don't know, a year ago, people would train a model to just predict between the 3 or whatever classes. Whereas in generation, you have the 50,000 possible next tokens. And then you're like, well, I'm actually just going to ignore 49,997 of these and only care about the probabilities for these 3 tokens, which I actually care about. So in some sense, there's like a lot of like, the model is doing a bunch of extra computation and that's not being used. Or it's like predicting some extraneous thing that you don't actually care about, whereas the typical classification setup just directly predicts what are the 3 classes that you care about. Does that make sense?
Maybe another way to think about it is a lot of classification typically is more like, I have the thing I'm trying to classify. I'm going to turn it into a bunch of features, like continuous features. And then I'm going to learn how to separate like these continuous features from other continuous features by drawing some decision boundary or like, somehow, or learning a neural net that separates them. And we're kind of doing we're taking a weird approach where we go through some complex computation that in the end results with a class, but we're not going through this step of like generate these distinct features and then try to separate like vectors of features from other vectors of features.
And does that normal approach require a lot more data?
Yeah. Yeah, the advantage of the treating it like generation is that that's what the pre-training task was. So you don't need to, that's the reason that you can do things zero shot with GPT-3, because the like classifier is pre-trained. You already have a classifier automatically for different tasks, like saying if a sentence is positive or negative, because you could just use the positive word as the classifier for positive and the negative word output as a classifier for the negative word. And actually, like that works better than like initially, like what the BERT paper did was just like throw away the final prediction of like what word is the missing word prediction, and then you just train a two-way classifier that just predicts like, say, like positive or negative. And then people have like later found that actually if you, for example, like initialize that two-way classifier, the positive or negative classifier, with the embedding from the word prediction task that you pre-trained, then you do much better at doing the classification task. Even when you do some fine tuning after, it's like just a good initialization to start with, because that classifier that you had been training for like what's the right word to predict contains useful information about the task.
I refreshed, and now one of the top questions is, some researchers think GPTN plus a small RL agent will realize AGI in short time scales. Is that realistic? Should we worry? Maybe the first question to think about here is, how hard is it to turn GPT-3 into any kind of agent? Like whether, so, and then the second question is like, should we worry about the sort of agent that it can be turned into? And I don't think we really know the answer. Or like, I think there is an interesting question, which is like, if you try to make GPT-3 more into the sort of thing that like kind of maps one like mental workspace to the next mental workspace, maybe by fine tuning it on some data about what kind of transitions between mental workspaces are helpful for certain kinds of tasks. How hard would it be to make an agent out of that? It seems like, I guess my intuition is, it seems kind of hard, but like not in the like clearly fundamentally hard, more like in the hard, but I could easily imagine someone coming up with some insights that make it like plausible way. And then the follow-up question would be, okay, should we worry about this agent? If it's like literally I guess it depends on what n is in GPT-N here. I think for GPT-3, I would like not really be worried about it. I'd be like, well, this will probably be like a very slow agent and a very stupid agent, and it can like only do very limited types of things. Whereas if it's like GPT-6, then who knows? All bets are off. What's your view, Ethan?
I think my most likely view is that we just hit this hardware plateau before we get something that will be able to do a lot of very powerful or scary things. Which I think would be like great for like having a nice model to like test alignment type methods and like exploring factor cognition and all these things with like a reasonably good model. But yeah, I mean, I think that does depend on like once we hit this like say 100 trillion parameter model, maybe it does turn out to be able to do a lot of things that that are like scary or but I guess I also struggle to think of like ways where it could be like used very poorly in a way that it, like a language model specifically, ways that it could be used really poorly. I think I guess the scary versions of AI tend to involve like a lot of RL and like being able to take actions in the world, like controlling a company or like controlling a lot of like robotic arms or like manufacturing or stuff that involves a lot of like physical things. Like so far I haven't seen any applications of GPT-3 that are like terribly worrying. Maybe like there are like things that are worrying about the model where like it shows biases like for different groups, it has like different associations, but it's not anything where I'd be like, I mean, I guess there have been maybe there's some instances of generating like fake news or stuff like that, and that's like maybe the biggest thing that I could see going wrong. But in terms of like the typical like long-term AI safety issues, I don't like foresee near GPTs being too much of an issue. But maybe other people. I'm even curious to hear what other people in the.
I mean, I guess the question here is about like maybe mere GPTs are not a problem, but maybe mere GPTs with a small amount of RL that like, you know, cause them in the right way and fine tunes them in the right way are a problem. Like, you know, you connect GPT to your email account and let it have Zoom meetings and give it some RL feedback signal. And then maybe you should start worrying at that point.
Yeah, I mean, I think that maybe it depends on like how much video, or I guess, I think video is necessary because like if you do need video to become a like full AGI, then I think that is something that like might take a good bit longer, where we like still haven't really figured out how to process video. And I think that's like a huge amount of information that humans get that makes us very intelligent. And that's probably like my crux there.
I guess that maybe we can add that to the key outstanding questions, like how much does video matter, or how much does interaction with the world more generally matter for building intelligent systems?
Oh, and another exciting direction is like language models that do incorporate vision and language, which I think there's been a lot of progress on.
All right, so we're kind of out of time. I think we should probably wrap up for today, but this was fun. I think we should do this more often.
Yeah, I enjoyed it.
All right.
This is great. Thank you, guys. I wish we could do like 10 more hours of this, actually.
Yeah, I have 1,000,001 more questions.
We'll do it again.
Thanks for coming, everyone.
You guys are the ones upvoting all of your own questions again.
Bye.
See you.
Bye.